I make videos to help my students score better in their STPM SEM paper. I hope my videos can be helpful for you too. Well, today I'm going to talk about partial fractions. In this first part of my partial fractions video, I'm going to talk about the forms and the methods that I need to use when I'm dealing with partial fractions. Before we talk about partial fraction, let us look at rational functions. Now, the reason why we need to do partial fractions is we have rational functions which we are going to use in our calculation. So we want to simplify these rational functions. Rational functions are actually functions that has polynomials in the numerator and the denominator. And the denominator, the qx, the polynomial for qx cannot be 0. There are two types of rational functions. If we have a polynomial with degree m and another polynomial with degree n, so if the polynomial here in the numerator, the degree is less than the polynomial in the denominator, then we consider this as a proper fractional function. However, if we have case like this, okay, where m is bigger than n, means the degree in the top numerator is higher than the degree on the denominator, we consider this as improper fractional function. Now, these are the examples. You can check it out. So, in improper fractional function, there are actually two types. You might see the one that where the numerator and the denominator has the same degree, or you will notice that sometimes the numerator has higher degree than the denominator. Okay, for this both method, you either will use long division to try to solve this. I will talk about them more in my second video about partial fraction. It is very important to be able to determine the correct form for the partial fraction decomposition of our given rational function. If not, all our process during our calculation, it will be wrong. So I will concentrate this video on a lot of examples on this. Okay. Now before we do that, let's look at the algebraic fraction first. Now we have rational functions where the denominator are linear factors. So if we see linear factors at the denominator, the format that we need is a over one of the denominator, one of the brackets in the denominator, plus b is a number, is a constant like this, okay, and it will give us a b over another brackets in the denominator. All right, I will talk about how to do all this calculation in my next video. Okay, the next thing is we need to see whether the denominator has a repeated linear factors. For example, like this case, if it is a repeated linear factors, means you have a linear and then you have a square or a cube, then when you have cases like this, then that element, okay, the fraction will be using this decomposition format. So, for examples, we have a rational fraction like this. Okay, once we break them into smaller fractions, it will look like this. Next one is when we have case where there is quadratic factors which does not factorize. Okay, it's very important. Does not factorize means, which means this quadratic fraction will be there and you cannot factorize it at all. So the formulas, the format that you are going to need is something like this. For examples, you have case like this. Let's look at the questions. Let's say if I want you to find the correct format. Okay, the first thing that you do when you get a rational function is to check the denominator. Okay, once you get the denominator, make sure it can or cannot be factorized. So for this case, it can be factorized. If it can be factorized, then the format that I'm going to need here is a over one of the brackets plus b over another one of the brackets. Let's look at this one. It is very obvious that it is all are linears at the denominator. So what we are going to do is we are going to put them into this format. Okay, so a over 1 of the denominator and then followed by b and followed by c. So if the linear denominator, the values on top here is just a constant. How about this one? This is a power of 3. So like I said just now, the first thing that you need to do is try to factorize this. So according to after I factorize this, I will notice that this element here are all linear factors. Okay, so I will bring out the x and then I will factorize whatever remains. So it is actually linear factors, which means when I do this format, I will need a over x, which is one of the element here. Then I will need b over one of the brackets here. And the third one will be c over another brackets. So I got 3 constant here. Next one, if I have something like this. Okay, you look at this and you say, oh, that's a repetition. So let's check it out. What we are going to have here is the repetition will have a over the first linear followed by b over the repetition and finally c over the third brackets here. How about question number 5? Well, in the first look, you will notice that this might be a linear, this might be a quadratic. But like I say, try to factorize this. Can it be factorized? Voila! It seems that x squared minus 1 can be factorized at x plus 1 and x minus 1. In this case, there is a repetition here. So the repetition is at x plus 1 and so I have x plus 1 squared here. So when I have a repetition for this one, what I need to do is that will be a over x plus 1, b over x plus 1 squared. See? You must be very careful when you do this decomposition. There are traps everywhere. So just be careful. Okay, of course, c over x plus minus 1, sorry. Now in the sixth question here, let's check it out. I have x power of 3 and then I have x minus 7 squared. So I know there is a repetition in a linear repetition here. But how about x power of 3? Now for case like this, we need to repeat this x 3 times. Check it out. A over x, b over x squared, and c over x cubed. You will treat this x like a repetition. So no matter how many power it goes, okay, you degree and the power, you check it out, and then you repeat it as many as it is stated in the degree. Okay, of course here there is power of 2, so you need to repeat this twice. So the first one without the square, and the third one, the last one with the square. So you have the coefficient or the constant here as A, B, C, D, E. Okay, and all these are numbers. Like I showed in the example just now, all these are numbers that can be calculated. I will deal with it in the next video. If you like, please subscribe, but my video has not ended yet. I'm going to continue with more examples. So please press the bell button and you will be notified whenever I have a new video out. Okay, in this example, what you are going to see is we have x minus 2 here and we have x squared plus 5. I will check whether this can be factorized. So if it can't be factorized, therefore my format will be a over the linear denominator and bx plus c over the quadratic denominator. So if you notice, if this is linear, this is a number. If this is a quadratic, that is a linear. So if you have a cubic denominator, I bet you know that the numerator should be a quadratic. So it comes in pairs. Now, let's look at this question number 8. Does that look like a quadratic? Yes. But can both these quadratic be factorized? I need to check. So after checking, I notice that this one can be factorized. I will get x minus 2 and x plus 1. So the format that I'm going to need when I deal with this partial fraction is I'm going to need to transform this into this format. So I have a over the first bracket in the denominator, b over the second one, and the third one is a quadratic. So the top portion here, I will get cx plus d. So I have 4 constants to deal later. Let's check out this question number 9. Try to factorize this. Yes. It will end up with 2 quadratic. Okay, I have x squared minus x plus 1 on one side and x squared plus x plus 1 on the other side. So I have a quadratic here. So for this case, the format that I'm going to deal is ax plus b over the first quadratic at the denominator and cx plus d over the second quadratic at the denominator. How about this one? Can you factorize them? Yeah, the first part can be factorized. The second part, it is a quadratic and this quadratic has a repetition. Okay, for cases like this, the format that you're going to need is a over the first denominator, b over the second linear denominator, and for the quadratic format, I will have cx plus d, but because this is a repetition, so for the first one, I don't have a square, but for the second one, I have a square. Then I'm going to settle with this a, b, c, d, e, f in using the format that I'm going to talk next. Okay? Next, I'm going to talk about the methods. Now, let me change my pen first. Okay? In the methods form, when you have a partial fraction like this, I will need to deal with my partial fraction by trying to break this into the correct format. So I'm going to choose a format and write out the format. Okay? Once I get the correct format, you notice that this one has three lines. Okay, these three lines means this fraction is identical to the one that we built. Next thing is we are going to get rid of the denominator and get this. So how do we do so? Now what we do is we will take the first part here, the first part, and we are going to multiply it. Okay, now where's my pen? Okay, there is it. So I'm going to multiply the whole thing with x plus 1 and x plus 2. So I'm going to take x plus 1 and x plus 2, and I'm going to multiply with the first part, 1 over x plus 1 and x plus 2. Close. And this will be, on this side, I will take my a over x plus 1 multiply with the same thing. So it's x plus 1 and x plus 2. Okay, I don't have enough space, so I'm going to bring the plus b to the bottom. But during exam, you don't do this. You have to write them all in a line. But if you are used of this working, you don't even need to do this step. Okay, I'm just showing you how I get the 1 equals to a plus x plus 2 and b multiplied by x plus 1. Okay, so I have b plus 2 there, and I need to multiply the whole thing with x plus 1 and x plus 2. Oh dear. Okay, you get what I'm writing, right? I'm sorry about that. Never mind, to save time, I just go and settle it. Okay, so what I'm going to do is I'm going to get rid of this whole thing. Okay, and I'm going to get rid of x plus 1 and x plus 1 here. That's why if you look at the answer here, I have a multiplied by x plus 2. And for x minus plus 2 here, I'm going to get rid of that also. So that's why if you look at the answer that I have there, I have x b times x plus 1. Okay, so that's actually how I get all this thing out. But during exam, it is optional. You do not need to show this working over here. Okay, you can save time by just copying this one and a multiplied by this and b. But if your equation is a bit complicated, maybe this working will help you understand it more. Okay, now next thing is I will need to find, okay, once I have already done with the decomposition, I need to be able to get the calculate the coefficient of A, B, C, D, E, F, that which I formed just now. So for basically this one is A and B only. So there are two methods to do so, and I'm going to show you both methods now. So the first method is by choosing a number. Most of the time, we will take the denominator. For this case, is x plus 1 equals to 0, any of the brackets inside the denominator, and make it equals to 0, x plus 1 equals to 0, so it's in negative 1. And I will take this negative 1 and fill in into this equation over here. So, like so. Okay, and I will get my answer very fast. Secondly, is the second bracket. So, x plus 2 equals to 0, x equals to negative 2. I'm going to use it, and I'm going to fill inside the same equation again, and I will get the answer. Of course, this is a simple question. I'm just talking about the method. Once I get both of them, okay, the A and the B, I will fill it back into my equation. So which means my A is 1 and my B is negative 1. So I will have negative 1 over x plus 2. In this method, number 1, you can actually choose any number to fill in. Okay, but the best numbers, of course, are from the denominator if you have any. But if you do not have any, you can just choose a number, simple number like 0 or 1, and fill it in and create equations and solve those equations. Now, in method number 2, right, what I will need to do is I need to expand these brackets. Okay, so a times x, a times 2. So I will have ax plus 2a, b times x, b times 1. So I have bx plus b. After I've expanded the brackets, okay, I need to collect all the one with coefficient x one side and the constant, or if they have x power of 2 or x power of 3. So you will collect all of them together. Okay, with the same x with the same degree, the numbers, you just collect them together. Next thing we are going to do is we are going to compare it. And for example, once I compare this, I will get equation 1 and I will get equation 2. So why is x plus b equals to 0? Because when I compare, I notice on the left hand side there's no x. Okay, there's on the left hand side here, there's no x. So the value, the coefficient for x is 0. That's why a plus b equals to 0. Now for the second part, I have 2a plus b, and this is a constant. So on my left hand side, the constant is 1. That's why I have this 1 here. Okay, once I'm done, I need to settle the simultaneous equation. Okay, I need to solve these two equations. If you need a video on that, please tell me in the comment below. Okay, so settle the simultaneous equation and you will get a equals to 1 and b equals to negative 1, and you will put that into your partial fraction. Okay, of course, with one example you can't go do much, but I will talk more about the methods and how to deal with partial fractions in my next video. Okay, so in the second part of my video, I will talk about the decomposition more and how to solve all these problems on partial fraction. Give me a like if this video is helpful for you. Please subscribe and you will be notified whenever my new video is up. Thank you for watching. Goodbye. Have a nice day.